A very good morning to everyone. Is everyone refreshed? How's your refreshment this morning? Is it okay? Good? Good, okay, thank you so very much. Alright, so welcome to this session of presentation, alright? So in the first session this morning, I'll be having like 3 sessions in total. In the first session, I'll be sharing about case studies. The case studies that we have done with our users, alright, throughout these years. Alright, I hope that by sharing with you guys all these case studies, we can learn together, we can enhance our knowledge on civil engineering together, right? That's for this morning's case studies. We'll see how we use MiTS software to ensure better design qualities, to ensure good results, and also to convince your clients, convince people that whatever your design is, it is sound and actually correct. Right? And so in the afternoon, I'll be sharing on BIM once again. You'll see how this MiTS software actually integrated with Civil 3D and vice versa. All right. And then I will also be sharing on the last session on this stormwater design. All right, about dynamic routings and also detention drain and stuff like that. All right. So just right before I start, I have to make some. Okay, you can see my screen, right? All right. Everyone can see me, right? Even though, including those who are in front, right? You can see, right? Okay, that's great, because I do not want to block your view. Okay, so now I hope that this is a learning session, all right? I hope that you don't see me as someone who is selling the software, right? I'm here to actually learn with everyone, to share my knowledge, and I hope that I can also learn from you guys, all right? But one key part of the learning is to ask questions, all right? So if you have questions, please do ask, all right? Because if you have questions, I think you just raise your hand, all right? Then our engineers will actually pass the mic to you. Then you can ask your questions, or you can use the feedback form, the one that we show, right? Later we will also show the QR code that you can scan and you put your question in, all right? Okay. So there is no way to actually learn except by asking questions, asking a lot of them. And I did not say this, right? This is coming from a guy called Richard Feynman, right? He's a very famous guy, a very smart guy. He is this Nobel Prize winners in the years of 1965. He won the Nobel Prize for something like QED, quantum electrodynamics. Any one of you know what does all these things means? QED, quantum mechanics. Know anything about that? Right, basically, it's the underpinning of what we have. It's a microscopic description of our real world. All right. So the second thing I would like to emphasize is that the slides will be automatically uploaded this evening at 6 p.m. So there is no need for you to take notes, right? I mean, you can take photos, that's your that's your freedom, but then you do not have to specifically take notes, all right? Because the slides will be updated on the websites at 6 p.m. sharp today. And for this session, I just hope that you can enjoy and you can interact, okay? Because I'm afraid that if you take the notes, then your energy, your attention span will be spent on taking notes rather than consuming and what I say, all right? And the third thing is that, okay, yeah, this is for the existing MiTS 3 users, all right? We have just released MiTS 3.2, all right? MiTS 3.2, along with all the MC integrators, all right? It is now up here, okay? You can just go and download it when you go back, all right? So that's the 3 simple announcements that I made. All right, so now let's move on to the talks of today, all right? Alright, so like I said, the morning session will be focusing on the case study that we have done with our users, right? I think they are pretty interesting and I think they are pretty instructive. That's why I'm sharing here. Alright, of course we will have some demos on the software, but that's for the later. Alright. So now the first thing is that is the speed improvement, like what Richard and Brian mentioned. We have a lot of speed improvements. Here is a more detailed, a more comprehensive figures of all the improvements, all right? So in MiTS 3, we actually did a lot of optimization under the hood, yeah, to make sure that when you use a MiTS 3, it is fast. But then I realized that coming from MiTS 2, maybe for you it is already fast enough, especially if your project is not too big, right? If your project is a very small one, then using MiTS 2 and MiTS 3 practically has no difference at all, right? But when it comes to large project, especially road project, the project whereby the engineers, they just import all this LiDAR model, yeah, then they can go easily up to a few tens of thousands of surveyor points, or even a few hundreds thousands of surveyor points, right? Then that could pose a challenge to the software, all right? Especially if your software is not recent enough, or if your hardware is an old model, all right? So I just want to take this particular examples up, all right? On this ECRL, right? The railway going all the way from this Kuantan, from East Coast all the way to this Klang, all right? I just want to take this study as a benchmark example, okay? This is actually a project of 450 kilometer road, all right? It's a very long road. It's a preliminary study. That's why there are not too much emphasis placed on the detailed design. All right. So this is actually it has a 30K survey points from Google Earth import. Actually, 30K is by comparison simple. It's a very easy thing. It's not frustrating. Okay. We have handled a project with many more survey points. I'll go to that point later. All right. So this is a 30K survey points for Google Earth import. All right. Because it's a preliminary study, the clients in this case is basically the state government of Pahang. They do not want to send survey points. That's why, well, the users, this handsome guy, Dr. Cairo from UPMSA, he is using Google Earth as a substitute. All right. For this preliminary study, Google Earth is already good enough because we are not stressing so much on the accuracy. All right. So as you can see, the client is Pahang State Economic Planning Department, and the job name is called Kajian Keboleh Laksanaan Spur Line ECRL Negeri Pahang. Right. And it means the feasibility of this spur line, right? And the consultant is Dr. Cairo, who is also teaching in UMPSA, and this is his handsome face. I interviewed him. All right, okay. Oh, yeah, just a refreshment course. You can see that this ECRL actually starts from Kota Baru, then ends all the way in Klang, and Dr. Cairo actually handles just a part of it, which is the part that you can see here. All right, so this is the part that he's handling, studying all the alignments, see how it goes. Okay. All right, so this is basically the rough guidelines of the projects. Okay. So now for this particular project, we did benchmark on this because this is sufficiently long, this is sufficiently large, so we find that it meets to the speed is a bit slow, okay? And MiTS 3, the speed has been enhanced by a lot, right? By maybe, in some cases, it can enhance up to the factor of 10, all right? Yeah, for this particular project. But of course, for your small project, maybe 10 or 20 kilometers, you will not see this kind of drastic improvement. Yeah, the everyday speed, even in MiTS 2 is already fast enough, so you don't feel it. But it's only when it comes to large project, then we see this drastic improvement in speed. All right, the larger the project, the more the improvement is. And we only benchmark certain specific parts of the project. So in this case, we are actually benchmarking on the UI operations. All right. So as you can see, the speeds reduces. Like in the first case, from 60 seconds to 1.3 seconds. In the second case, from 13 seconds to 3 seconds, and so on and so forth. So I'm not going to go through every single one of them. All right. And then and then we have another project. All right. That's the reason why I said 30K is actually chicken feed, because we have handled projects with almost 1 million survey points. All right, and then it is also a good candidate for optimization, obviously. So as you can see, the improvement, the increase is actually a lot more. Like for example, you go from like 5 minutes to 3 seconds, for example. Okay, and going from 4 minutes to 4 seconds. This kind of drastic improvement. I would say that as a general rule, the bigger the project, the more the improvement is, right? That's the idea, right? So this is what we have in MiTS 3, the kind of optimization that we do. So just for your curiosity, let's see what is this project about. So we have posted the whole case studies on our websites, all right? It comes in the link of the software, all right? So, yeah. So, yeah, this is a very detailed write-up, okay? So you can see right here. Okay, so basically I just get my information from here. Okay, and then go on. Okay, wait. All right. So, wait, jumping ahead of me. Okay, all right. So besides these two benchmarks, we also conduct automated tests daily. All right, because as we developers fix the code, as we make changes to the software, sometimes it may introduce bugs. That's why we have this automated tests, yeah, running every single night. So for every check-in, we will be like rerunning all of our test suits. All right. At the end of the day, we will rerun all our test suits and then compare the results with the day prior. See whether we have any bugs or not, the regression bugs, whether the result run off or not. So sometimes you may find that, maybe not for our software, but for other software, how come the result always change from version to version? Right? Have you guys ever encountered that? Right? When you run a particular software, the result in version 1 is different from in version 1.5, it's different from version 2, and it's different from version 2.5, and so on and so forth. Alright, so this is the kind of regression, the kind of problem that we really want to avoid. Because you understand that you actually depend on a consistent result. Yeah, for engineering, sometimes one result is as good as the other, right? Maybe the result changed because of the parameter change. But then what you do not want is that when you run in different versions, then the result is different. Then when you go back to the original developer, he told you all the result difference is to be expected because of, well, engine change. This is not really enough answer, right? Then how are you going to justify to your clients? Oh, my result changed already. Or in a better case, the result changed all because of the new settings and the default setting changed. Right? These are the things that we really want to avoid if possible. Alright? We want to make sure that when you run in version 1, version 2, version 3, version 4, all the results are the same. If we have new settings, then it will be put as a flag or something like that. So this is why we have this automated test run. And for this, it is concentrating more on the engine part. And as you can see, the improvement is not really that great, I would say. You do not have up to like 10 times of improvement. No, this is not happening with the engine. So this is why when you use mixed tree, sometimes you don't feel that much of a difference of this, because this is because of all these factors. One is that maybe you are just running on the result side, so the improvement is there, but not as much. Yeah, another is that your project is small, so original mixed tree is already fast enough. So yeah, you don't see much difference. But if you are running big projects, if you are really directly loading the survey points right from the Google Earth or LiDAR, then you will see a lot of difference, right? Alright, okay, here's another benchmark. Okay, now what I'm trying to show here is that how we compare with Civil 3D in terms of everyday operations. Alright, again, this is actually a huge project, I would say. Right, this is a zoom operation. Alright, as you can see, okay, now as you can see, when you zoom in Civil 3D, when you have a lot of survey points, yeah, it is a bit lagging. Right, it is a bit lagging. Right, it is a bit lagging, as you can see yourself. But if you zoom in MiTS tree, then it is a lot more smooth. Right, a lot more smooth. So this is this is just the software difference. I don't know how to comment. Okay, this is yet another example. All right, when you have when you want to pen. Alright, so you can see the kind of operation speed on the Civil 3D side. Right, on the mid side, it's a lot more smoother, I would say. It's a lot more smoother. So let's move on to the next thing. This is also on object selection, right? You have so many survey points and you want to select one single survey points in Civil 3D. So see this time you really have to see carefully, right? Now Civil 3D is processing. Let's give it some time. Let's give it some time. It is still processing. My computer doesn't hang. Right, okay, now it is selected. It's selected. On our side, we select one point. See, immediately selected. Right? So yeah, this is just a replay of what we have been going through just now. Yeah. So yeah, as you can see, if you want to select a lot of survey points in Civil 3D, then it will take a very long time lah. Especially when your survey points plans is very big. All right. Okay. So any questions on this? This is basically what I want to show you about the speed improvement and the kind of work that we have done in making large projects accessible. Any questions? All right. If no more questions, then I would like to talk about a few case studies that we did with our users, right? It's about disputes. It's about earthwork quantity disputes, all right? I'm not too sure how many of you ever have this kind of dispute with your clients or with another group of consultants that your clients hire. Anyone have any this kind of experience? It's actually quite a thrilling experience, I would say. Anyone have it? No? So your clients just sign off everything you put in. Is that the case? They never question you. Wow, you guys are super lucky, huh? Alright, so usually what happens is that the developers, they are very cost conscious, or because they want to, control, right? Either they are very cost conscious or they want to control, right? They want to nail down every single thing, especially in terms of cost, right? Because people are doing business, right? So you want to know how much you have to put in exactly and how much you can gain exactly in what kind of time frame, right? I mean, if you are the developers, this is the same thing that you will do. You want to know how much exactly I invest today and how much exactly I can earn tomorrow. I want to have zero uncertainties, right? So it is your job to give him this kind of assurance, all right? And sometimes even he listens to you, but then he still feel that, I need to get a second opinion. I need to get a second opinion, all right? Maybe from contractors or maybe just from another group of consultants, all right? So that I can know, I can sleep well at night, all right? In this case, this is a more extreme cases, all right? Okay, they say, okay, how can you actually minimize my kind and fuel cost, all right? If you propose a number that they are not happy, then they say, I want to get another group of consultants that can make the numbers for me, all right? Then you have consultant A and consultant B arguing with each other, trying to convince each other that they are both right, all right? Or they are just trying to reach a middle ground, a compromise. So it is under this kind of background that we have the opportunity to catch a glimpse of what is going on behind, okay? All right. So, what is at stake is actually, well, the pride and also reputation, all right? Because you want to be known to your clients, to your colleagues, to the profession at large, that you are a reliable consultant and that you can justify your results, all right? So this is why it's at stake here. And so people ask me, hey Soon Hui, how do you solve it? Yeah, they just come in with an email. We have this problem, all right? This is the cut and fill from us, maybe just a screenshot. And this is a cut and fill from our contractor, and not even a screenshot, just two numbers. Or maybe sometimes not even two numbers, but just a line. Your result doesn't agree with the contractors. Please check. So how to solve it? Anyone has any ideas? The answer is, I don't know. in the absence of further details, there's nothing we can do, all right? I really don't know how to solve this kind of thing, all right? I'm not supposed to know, by the way, all right? So, but then I do have some toolbox which I can share with you. That's how you can usually resolve this kind of issues. And then I will demonstrate this toolbox through a few case studies, all right? Now, let's go to the first case. This is a 67-hectare project, all right? This, I think, if I'm not mistaken, it is coming from WKL Design, right? WKL Design. So basically, it is like 2 plots of land, okay? 31, 36, in total 67 hectare, all right? So we just use a baseline figure from this Bukit Jalil Stadium. The whole complex is called KL Sport Precinct, all right? It is around 120 hectares in total, so it's like half of that, okay? So I asked ChatGPT, let's say 67 hectare, what is the ballpark development figure? Yeah, the total cost of development for this kind of sports stadiums, sports precinct is around 1 to 2 billion, right? 1 to 2 billion. So now, okay, so this is how the project looks like, right? So the project is that we have actually there are like 2 plots of land. One is A and one is B. Okay, all right. So this is how it looks like. So okay, we go to the difference first. Then we talk about the money thing later. All right. So the user just say that, oh, okay, our contractor, they use Civil 3D, and this is the number of cut and this is the number of field. All right, it's 1.6 meter cube in cut and 1.6 also 1.6 meter cube in field also. All right, but in MiTS, the result is only like a 1.5 meter cube. All right, 1.5 meter cube for the cut side and for the field side. The difference is around 6 to 7%. Right, the difference is around 6 to 7%. So now we have an argument. Yeah, when we heard this, we do not have any other information except this one. We do not have the original file. All right, so we try to solve the problem from our side, all right, based on our experience. All right, so yeah, okay, let's talk about money right now. Okay, so we just do a very rough estimation, assuming that it costs around 8 ringgit for every meter cube of excavation. I just don't care about the difference between cut and fill first at this moment. We just assume as a blanket figure, it's 8 ringgit per meter cube, right? And then, so we just do a rough summation. It's like 3.2 million meter cube for both cut and fill in Civil 3D side. And for MiTS, it's only 3.0 meter cube for cut and fill for cut and fill. So the difference is around 222k meter cube, all right? So we use this number times by 8 ringgit. So it's around 1.7 million, right? 1.7 million, all right? So the result and from us and the result from the contractor, it will actually generate at around 1.7 million ringgit difference, right? So if you are the clients, if you are the developers, who are you going to believe, right? I think most of the developers, they will want to believe the one with a lower figure, correct or not? Yeah, they want to believe that, I better opt for the one lower figure lah. Oh, in this case we win. Yeah, great job, we win. But as an engineer, do you think that this is well satisfying? No, it's not satisfying, right? We actually want to reach an agreement. We want to find out what exactly caused the difference. Yeah, that's the idea. So here we go. We go down the rabbit hole. Okay, now, we talk about money again. Alright, so assuming that for the developer side, 1.2 billion for 67 hectare, is 10% gross margin. Is it a good margin or not? 10%, what do you think? Okay, ChatGPT said 10% gross margin for developers is actually not so good. But anyway, we just use this figure. And then we assume that it's like 5% net margin before tax, right? So it's 60 million, right? 60 million. But then this 60 million, you are not going to collect immediately, right? Maybe you have to fork out first, and then only you collect back later. So 60 million, if you do not have sufficient cash, you have to go to the bank and do a bank loan, which means that your margin is actually will be further squeezed. Okay, so let's say if it is like there are 2 million uncertainty, 2 million meter cube uncertainty in your cut and fill quantity, it's like almost 3 to 4% of your profit. This is eating purely into your profit. Okay, so we need to find a way to actually reduce that, narrow it down to make it acceptable to our clients. Okay, right. So the first thing that we check is the 3D view. As you can see, in Civil 3D, this is how it looks like. It's not fully convex like us. All right. So, but then overall, you cannot immediately tell what are the differences. All right. You cannot immediately tell that or which one is correct or not, and you cannot immediately tell why they are different. But you can can tell that the 3D view doesn't look the same. All right, some of the parts are not being calculated, some of the parts are being extruded. All right, so okay, so we try to lock it down. In MiTS, we can actually adjust a factor called alpha value. Okay, later I'll show also. There's an alpha value that allows you to simulate the shape of Civil 3D as much as possible. Right, as much as possible. So we try to adjust, play around, and this is the best that we can get. Right, adjust, and then this is the best that we can get. We just want to check whether this is due to the boundaries surface covered by Civil 3D and the boundary surface covered by MiTS are different or not. We just want to check whether this is the case or not. Alright, so yeah, and then after we adjust, we find that there are some differences. We move the needle, but really we just move the needle back a little bit. Alright, the difference is still like between 5 to 6%. It helps, but not by a lot. Alright, it's not by a lot. Then, yeah, so we really have no choice, but then we need to actually get the files, get the project files, the Civil 3D project file from the contractors. And then finally, when they submit the files, then we can start to do something now. Okay? In the end, we really do get it. So what happens is that, okay, we are going to use this MC integrator to actually convert the Civil 3D file to MiTS file. Okay? So this is the process. I just let you see a video of it. Because later on, we'll be doing a hands-on demo of this so you can see more. Alright? So this is how we do the actually synchronization, define all the mappings, right? Right. In this case, we just want the surface, but nothing else. So that's where we are. Okay. So yeah. So this is how we do it. Okay. And then this is how we actually import it. Right. Now this time we do the importation. Right. Now it is already being imported. So we just do a run of it. Right, just compare the two surfaces, the one, the original one, and also the one from Civil 3D. All right. So this process, I think you guys already know fairly well, if you are our user for long. We do not change this operation. All right. Okay. So this is the result that we get. Okay. So now this is what really makes a difference. All right. The moment we get the original file, we can actually we convert the Civil 3D file to MiTS file, all right? And then we run the same thing again, all right? Then we can find that now we can get almost the same result, right? The one in Civil 3D is like 1.62 meter cube, right? For the cut, but then in Civil 3D is 1.62 meter cube. In MiTS also 1.62 meter cube, right? So the difference is only 0.34%. Alright, this is very, very good. Okay, there are some differences due to software differences, which doesn't really matter. But then we achieve our goal, right? We get the results that is almost the same with the contractor, and the same also happens to the field. Okay, so this is how we solve the dispute here. Right? Okay. Now you may ask, how come the first time the results are so very different? Okay, we have to understand why the first time the results are so very different. All right, the reason is because I'm pretty sure you also know sometimes the surveyor actually takes a few rounds of measurement, right? And when they pass the surface profile, they pass the survey points to you, and they pass the survey points to other parties like contractors, or they pass it to the second contractor. Sometimes they pass a different version one, right? They pass a different version one. So this is why when you want to do the comparison, you find that you are actually not comparing apple to apple. You are comparing the version 1 of survey points profile to the version 2 of survey point profile, right? This can happen, and you wouldn't know because they all look very similar to the first approximation, right? When you look at it, you find that they are not so much different. Yeah, the survey themselves, they also don't know that they actually mix up things because people can make mistakes. So which is why we always need to have a way to actually interoperate, right, between different softwares. And also we always have to have a way to actually go to the original source if you want to do the comparison, right? So this is what it is. And in our MiTS software, we have this one feature, so which will actually show you, which will actually superimpose different survey point profiles on top of each other, all right? And not only that, we can actually also see the points of it, the Z values of it, all right? So this is extremely handy. You see, in this case, it's extremely handy. We find that a single point is there in both the MiTS and also it's there in the contractor profile. The same point is there, but then the Z value is slightly different. Slightly different, right? Maybe about like 5% different, right? And this actually explains why the cut and fill quantities are different, right? And so this actually explains why the quantities are different. And this difference is actually very small. You will not notice it unless you actually actively control every single point. Yeah. So this is how we are thinking. That's why we were thinking about putting this feature to do the direct superimposition to let you direct compare the Z values. All right. So this is the kind of thing that goes into our software. All right. Here's another case study. I want to catch a break, but any one of you have any questions? Yes.
Go back to the first study number 1.
Okay.
Done in around 20 means that data from this are calculated to be calculated in Civil 3D.
Okay, your question is that I have shown from Civil 3D to MiTS. So do we do the round trip from MiTS to Civil 3D? Okay, I'm very glad that you asked, because this will be the presentation topic for this afternoon. Yes, we do have. All right. Any questions? Oh no, not for this particular project, but we do have another project that shows the result. Okay, yeah. Oh, but anyway, I think I think I just try to pull up the blog post for us to quickly go through if you want. Okay, if you guys don't mind. Anyone object? I just put out this blog post real quick to compare the results. All right. I need to take off my glasses, I'm getting old. No, take off my glasses. Alright, yeah, so this is what we did when we do the comparison from MiTS to Civil 3D. Alright, I mean, I just jumped ahead of myself slightly, so I hope that you guys don't mind. But basically, in MiTS, we can synchronize to Civil 3D using a few entities, so to say. Yeah, we can synchronize to CAD entities like polymesh and stuff like that. If you are into Civil 3D, you know what I mean, the polymesh. But this is just CAD level, it's a bit too low level. But in MiTS, you can now synchronize to civil levels, or I call it bread lines levels. All right. For if we sync using bread lines levels, then you'll find that the discrepancy is very, very low, right? This is the kind of percentage that you get, right? Yeah, so we have a comparison project here. Yeah, so basically in Civil 3D, we can actually model everything for the surface actually quite perfectly, I would say. Right, we can model the slope, we can model the drops very well, as you can see, you see. So in Civil 3D, if you want to model a drop, it's not easy. You have to use wall break line and stuff like that. But then in software, we can handle all these things seamlessly. Right? If you want to model gradient, also can. Yeah. So yeah, this is how we have. Okay. I think later Patricia will show more on this. All right. Yeah. Okay. So any more questions before I move on to another case study? No more questions. Okay, all right. Yeah, so another case study. Okay, let's move on. Okay, this is old slides. Where am I? Oh, yeah, old slides really. Okay, now this one. Okay, this is about Batu Pahat. Around 84.6 hectare. All right, this is also a dispute. Another dispute by our user from TPPay with the contractor, all right, the contractor. All right, this is how it looks like lah, okay, the site, the before and after, yeah, the blue line, or is it green line? It is the before the original one. The red one is the SB one, all right, that one is the SB one. So again, the user come to us and say that the result does not match with another group of contractors. So, all right, okay. There's some nuances lah. Okay. On the field side, it actually matches. Okay lah, not too bad lah. Okay. The fields I make a mistake here. This difference should be belonging to the cut, right? The more than 25% is the cut. The field is less than 10%, right? So this is what it is. So the field side is still okay, maybe. Right? But for the cut, it's not so good. The difference is more than 25%. And now, in this case, we do the calculation. There is around 0.66 million meter cube. The difference is around 2 million in terms of excavation cost. All right. In this case, doesn't look too good on us because the developers will definitely favor the one with the less kind of feel, right? If given a choice, of course I will pick this lower kind of field. It saves my cost. So can you make the number for me? Can or not? Well, I would say cannot lah, because this is mathematics. How are you going to how are you going to argue with mathematics and physical law? You cannot. 1 plus 1 is always equal to 2. Alright? So yeah, so we have to find out the reason. If we cannot make our numbers as good as they are, then at least we can try to explain and justify why this is our number, right? That's the best we can do. Alright? So that's the issue. People will ask, is your software result even correct? It's even correct. Okay. Yeah. But let me be frank with you. There is no way we can be sure that anything is always 100% correct. Right? Everyone agree with me, right? No one can be sure that everything is 100% correct. Even your perception can be wrong. Right? Same goes for the software, right? But we actually build in a lot of things to help you check, to counter-check our own results, and also to counter-check other people's results. At least you know why you are getting this result. We can have a lot of validation and verification. All right. So let's try to see some of our improvement on this. Right. To see how we actually validate against ourselves using different methods, and also to basically let's see how do we make sure that our result is consistent. Okay. There we go. Okay. Wait, let me just pull it out first. I don't want to let you see my YouTube playlist. Play speed, I set to 2, so that people will not get bored. Oh my goodness, how am I going to move it to the other side? I have no choice, I have to let you see my YouTube playlist. Twice the speed. Okay, let's speed it through. I will make some commentaries along the way. Okay, so this is a project, and then this, as you can see, this is the overlapping between the original surface and the execute surface. Okay. So we have a few methods. One is DTM. You already know very well. Basically, you break everything into triangles, and then you compare the triangles between two surfaces. So this is the result. Okay. Now this is our result. Okay. Can we stop? Oh my goodness. Think faster. Wait. Stop. Okay. So you see, this is our results. This is just the data coming from one source, right? The DTM. Right. So this is another source. We make it into a grid, right? And then we try to make the intervals 50. Yeah, let's see how it goes first. If we want, we can always make the interval or the grid size smaller. So okay, this is the number, all right? Okay. 248, right? Just now it was 257 something, now it's 248, right? Okay, N area. Okay, 253, right? 253, right? So it's well, yeah. Then you can line them up for comparison. 257, 248, yeah, 257, 248, and then let's see what we have. Yeah, 253, right? So that's the thing. So it's about there, I will say. Okay, and then yeah. So these are other further checkings that I would say. You can also verify that the points are actually what it is given by the survey, all right? Because sometimes when you interpolate the points, you will find that the result looks very convincing. But then when you zoom to the actual point, like actual point here, there's a gap here. Be careful. All right, there's a gap. There's a point here. It is not 55.64. 464, right? So we have this interpolation here, all right? So as you mouse more over, then you will see that this ground level actually changes. So you mouse over to here, this exact point, you should be able to find that this one actually gives you exactly 59.464, right? This is the idea, okay? If it is not like that, then maybe something is wrong with the meshing or what, okay? Okay, so you see, okay, then you see, okay? Yeah. So as you can see, this is what I meant just now, right? For that on that exact survey points, the interpolated values and the given value must agree. All right, that's the idea. Then you can have confidence in your own the results. Okay, so yeah. So we do the same thing for this second set of survey points. Basically the same story, I would say. Same story. Okay, that's the end. Okay, so we continue. as you can see, for this particular project, the cut results actually varies between 248 and 257 for all these three methods. But still, it is a long shot from this, all the other software like is 1.91, all right, still a long shot. But then, at least after you go through this kind of process, after you compare between different methods, you will actually generate a feel for your own results, and you will know, you will be convinced deep inside your heart that whatever that you get is the correct one, all right? And so how this other software get the value, well, that's not really your problem already, all right? As long as you are convinced that it is correct, then it's already good enough, all right? Oh, we have gone through this, okay? So we also have detailed elements. You can even do element by element checking, all right? So later we will show. Okay, so now this is where the Civil 3D comes in again, right? This time we use the MC integrator again to actually transport MiTS to Civil 3D, okay? In Civil 3D, the result actually links a lot more closer to our result than the other party, all right? It is 248, as you can see, 248 here. 248 here. Just now we got between 248 and 257. So for this Civil 3D surface, we are using a DTM surface. So it should compare with 257 now. All right. So 248 is a lot closer to 257 than 1.91. Right, 191. Okay. So after this, then we are actually very convinced that our result is correct. All right. Yeah. So between 257 and 248. The difference is around how many percent? I think less than 5%. Yeah, it's less than 5%. All right. So do you still want to dig down the rabbit hole and find out exactly why there is this 5% difference? Can we? Yeah, I think we still can. All right, we still can. All right. Yeah, basically, I just give you hints. I want you guys to try if possible. This is the surface in Civil 3D after we sync from our software. This is how it looks like. And this is how the surface looks like in MiTS software. So by just looking at these two images alone, you do not need other information. By just looking at these two images alone, can you at least provide a guess why there is this 4.5% of kind of view difference? Anyone would like to try? Anyone like to try? Okay, you do not even need all your civil engineering knowledge. By just looking at these two images alone, maybe if you are good enough or you are attentive enough, you can already give a very good guess why there is a difference. I heard murmurings, but I do not hear any voices, any volunteers. Come on, raise your hand. Sure, you can take a shot or two. Any takers? Or maybe the incentive is not strong enough. Maybe if you can guess, I can give you some goodies. Is it? Will that incentivize you to guess? Anyone want to guess? Just take a guess. There's no shame in guessing wrong. Okay, I just spilled the beans. I'll tell you the answer. The answer is that there's this small differences here, right? In Civil 3D, it is a bit cut out, right? It is a bit cut out. But in our software, in MiTS, at least the one that we use to compare the difference, it is not cut out, you know? It is actually quite straight, right? It is not being eaten into. Now, you may ask, how come the number of survey points is exactly the same, the positions, everything are the same, but then the interpolated surface are different? It can be different because depending on how you interpolate it and depending on how you actually adjust certain parameters, you can actually have a fully convex survey point boundary like this one. Yeah, this is what happens when you set the alpha value, we call it alpha value to maximum. Then it covers as big as possible the area for the survey point area, right? But you can also adjust the alpha value to the minimum so that it covers as little as possible, and yet still covering all the survey point, right? So this is possible, you see. So you can actually adjust this value and in our software, all right? You can do this in our software, but then you cannot do this in Civil 3D, okay? Which is why we actually make the adjustment and then we compare the result for this one final time. Okay, right. Oh, I'm jumping ahead myself. Let me just show you this particular thing. Right. Let me open up this project. This is how it looks like. Now, this is already been just the outbound. Wait, I think, wait. Okay, let's try this, do the superimposition first. Show all, and then we have all of them, yeah? So as you can see, there is a kink here, right? So there's a kink here. So this is after we tune the alpha value, all right, to this particular value to get this particular shape, all right? So what happens is that when we try to run the earthworks, calculate, yeah, comparing these two survey points, then we'll be able to get the exact same match as Civil 3D. All right, let's just give it a bit of time. So as you can see, this is numbers. We finally made the numbers 248.90, right? This is the numbers that that can compare very well with Civil 3D. Civil 3D number, where are you? Right here, 248.1. So it compares very well with Civil 3D, all right? So here we go. Okay. So let's say if we just adjust this alpha values by a little more, right? So as you can see, the surface profile actually changed. Surface profile actually changed, all right? So when you do the calculation again, then the result will be different. Yeah. So you can do this in, you can adjust the alpha values in our software, but not in Civil 3D, which is why we have to fit to Civil 3D rather than getting Civil 3D to fit to us in this particular case. As you can see, it's 252, right? It's 252. Yeah. So that's why it is. Okay. So now let's go back to other things like we want to compare the. So now, as shown the video, we can do this end area input. So we want to have more comparison. Okay, move here. Right, then we do a calculation. Oh, this guy here. Calculate volumes. Your vertical grouped. Okay, we can do side-by-side comparison, which I really loved. Alright, so as you can see, the numbers are here. Alright, so they actually agree quite closely. The net import and export actually agree quite closely. Alright, this is how you get a feel to ensure that the results are correct. At least your software has no bugs. Okay, let me put it this way. Now, let's try another thing. Let's close this. I think this is a bit. Okay, let's try to define this grid first. Okay, let's add first. And we calculate. Okay, so again, let's try to compare. Yeah, so 252, 252, 209, and 209. So they actually agree quite well with each other. Yeah. So this is how you actually build out your intuition, and you actually are convinced that whatever that you get is actually correct. All right. Correct. Okay. So all right. So I want to show you another thing which is shown in the video just now. You have demo. Let me just try to. Okay, oh, this is getting okay. Right, like I said just now, I want to delete this one first. Or else it is, no, I just don't want to delete. Let me just try to hide it. Hide all the things. This one. Yeah, it's hidden behind. Okay, cannot see. Okay, let's try to hide all the brick thing. Yeah. In area. That looks better. Okay. Cannot see. Okay, let me just try to find where is it. Okay, now it's cleaner. Okay, so like I said, you can actually superimpose two survey points profile together. This is how it is. So let's say if you want to just see only one, this already show all, okay? Then this survey point group, okay? So let's say you want to show the values of it. Yes, you can see the values, yeah? So these Z values, you can show more than just Z value. XY also can, Z also can, and so on, okay? So let's say if you have 2 points superimposed, then it's very easy, all right? You just go to another survey points, right? Then you just change show value to yes. So this is how you look like. So this is how you can tell whether the 2 points, the supposedly same points are really the same or not, okay? So this is what we have here. All right, okay. All right, so, okay, yeah, any questions on this? Okay, no question, no question, okay, we just move on. Okay, now, so I think a good earthwork software must have CCTV lah, I would say, right? CCTV, it must be customizable, right? Right, you can actually change the things according to your needs, all right? And then it must be consistent, right? And not only it must be consistent, but you have to be able to prove that it is consistent by having this kind of different methods cross-checking with each other, all right? It must have transparency, meaning that every single step of the calculation, you can actually go through, check, all right? Because really speaking, like what I said just now, we don't know, there is no one who can guarantee that the software has no bugs, right? No one can guarantee that. But then, what we can guarantee is that every step is actually properly listed out and is transparent for you to check, for everyone to check, all right? And also again, verifiability, all right? It must be able to be verified, either internal verification or external verifications, all right? So things, like I said, things not only have to be seen as correct, right? A lot of AI things nowadays, they look very real, right? Yeah, something like Sora, they look very real. But then when you take a deeper look, you'll find that the movement there is not according to the law of physics, which means that they are not true. They are not correct at all, right? You can get away with this if you are doing AI or if you are just doing visual stuff. Things just have to look real, look convincing, but then in terms of engineering software, it has to be actually correct. Yeah, it has to be actually correct and verifiably so. And this is where I think we are actually are better than Civil 3D on this. Because Civil 3D, in a nutshell, is still modeling software, alright? It was built on top of AutoCAD, which is actually a drafting software. It's only later when Autodesk bought over some Civil 3D products, some earthwork products, they then rename it into Civil 3D. Yeah, but then all the legacy garbage that is imposed by AutoCAD is actually also happening on the Civil 3D side. Yeah, which is why when you want to go to this kind of checking, which is why when you want to customize all these things like the surface, the alpha values and stuff like that to get to compare apple to apple with our software, you really cannot do that because Civil 3D was not built for this particular purpose. Alright, it was built more for AutoCAD purpose, and then only later on it evolved, so to say, based on the legacy framework, and then become Civil 3D as we know it today. Alright, so this is what it is up. Alright, so before I move on, any questions? Or maybe you are already very bored and you want to go for lunch. Alright, okay, if you have no more questions, I mean if you have questions later you can approach me privately, no problem with that. Alright, so if you have no more questions, then I'll pass the time to Patricia. Right, she'll be showing watershed delineation. And I can guarantee you that it is all software demo, so it is not as boring as my presentation, all figures and numbers. Okay, alright, so let's put our hand to welcome Miss Patricia.